Alright, calculate the magnitude and direction of the electric force acting on QC. So QC is the one over here. Assume the charges are in vacuum. Right? So basically what you have to do is kind of figure out two different forces. As you know, QC will be affected by QB as well as QA, and then you're going to have to either add them or subtract them depending on which direction it's going to. Alright, let's go step by step. So let's start with QA. So force due to QA. So this is when QA and QC interact. So my facts would be, Q1 would be my QA. So maybe I'll write QA just to be, micro is 10 to the power of 6. I'm just going to write that straight away. My QB, not my QB, my QC is 9 times 10 to the power of negative 6. My R, I got to add these two together, hopefully you understand that. So that'll be 75, 20 plus 55, 75 centimeters, which is 0.75 meters. And that's it, I should be able to find it. So let's give it a go. Force equals K, QA, QC in this case, R squared. So if I just chuck that in, 9 times 10 to the power of 9, 3 times 10 to the power of negative 6, 9 times 10 to the power of negative 6, divided by 0.75 squared. So if I just chuck that in the calculator, I should get 0.432 newtons. Now I'm not done yet because I need to make sure I write the direction down. So let's have a look. It's a positive and a positive, so they would be repelled from each other. So technically, which way is it going to go? It's going to affect my charge to go that way. So I'm going to draw that direction in. Right, so one more. I've got to do the force due to QB now. So I'm only looking at QB and QC. So let's write some facts down. QB is 5 times 10 to the power of negative 6. QC is 9 times 10 to the power of negative 6 coulombs. And my R is 55 centimeters, which is 0.55 meters. Always make sure it's in standard unit. Right, again, I do the same equation. I'm just not going to bother writing it here because I need more space. So once I do my force equation, it's over here, so have another look at it if you need to. It'll be 9 times 10 to the power of 9, 5 times 10 to the power of negative 6, 9 times 10 to the power of negative 6, divided by 0.55 squared. Right, if I put that in the calculator, that shouldn't be too hard. It gives me 1.34 newtons. Now, we've got to figure out the direction, don't forget that. Have a look, it's a negative and a positive, so are they going to repel or attract? Hopefully you understand that they're going to attract to each other, so this one is going to go that way. So it's going that way. So now we have to find the total sum, so total charge, right, is going to be my force from A plus my force from B. So I'm just making notations to myself. Well, my force from A was 0.432, and I'm going to leave it as a positive number because going right over here is normally like my positive direction. Now this one's going negative, as you can see over here, negative direction the other way, so I'm just going to put that in negative 1.34. So I like to just do the plus and the minus, or you can figure it out and then decide which direction it's going to depending on which number's bigger. So it's up to you really. So do 0.432, take 1.34, and what you should get is 0.908 newtons, and it's a positive number, so it must be, oh no it's not, it should be a negative number, so it should be going this way. Right, so if I just do that, if I just take the difference first, I do that and then I figure out which number is bigger. Well, going to my left is bigger, so it obviously is going to end up going left. So once you draw the direction, you don't technically need the negative. So it's 0.908 newtons going to the left side, and that's it.